Introducing the new GraceSense predictive maintenance line of smart devices for the Industrial Internet of Things, or IIoT. These new GraceSense products combine low-power wireless smart sensor technology with advanced data analytics to help asset managers maximize the impact of their maintenance budget and protect their high-value assets from unplanned downtime. By remotely monitoring critical equipment and issuing SMS or email alerts when anomalous or problematic behavior is detected, GraceSense technology can help improve productivity and reduce downtime in almost any industrial application. Equipment uptime directly impacts plant productivity and output. An unplanned shutdown due to failure of improperly maintained equipment is among the most costly scenarios a facility can endure. In order to curb this potential major economic loss, many facilities today use a wide array of maintenance methods that include routine physical inspections and condition-based monitoring in an attempt to spot equipment failure before it occurs. Leading indicators of failure typically depend on the type of equipment and can include changes in things like vibration, heat, power consumption, airflow, or pressure. The GraceSense vibration and temperature node was designed specifically with these challenges in mind. By focusing sharply on two of the leading indicators of failure in rotating equipment, the vibration and temperature node continuously monitors critical assets and can alert maintenance personnel in real time when it detects behavior indicative of bearing, rotor, or shaft degradation. These vibration and temperature nodes share their data wirelessly with any GraceSense cloud gate located nearby. From there, local vibration and surface temperature measurements can combine with other measurement data like ambient temperature or current draw and push to either a local or remote cloud in order to improve the accuracy of the system's predictive capabilities. Once GraceSense IIoT hardware is incorporated into a facility's preventative maintenance program, this technology comes to life through our web-based maintenance hub, which is used to configure the system, view current system status, analyze historical data trends, and generate periodic reports. The hub is also where users can create customizable alert messages with step-by-step remediation instructions designed to allow even new or untrained personnel to address critical issues as they arise, regardless of the time of day. The GraceSense predictive maintenance line of products feature a flexible architecture combined with deep technical expertise employed by Grace Engineered Products, and has already been proven in some of the world's most challenging operational environments, from long-span bridges to U.S. naval warships. With so many possibilities for predictive maintenance on the horizon and a team of thought leaders at its helm, GraceSense continues to provide innovative and scalable solutions to address the industry's ever-growing demand for higher reliability and reduced maintenance resources.
So, good afternoon, everyone. Thanks for joining our webinar today on the topic of reliability essential for a safe, cost-effective, environmentally friendly operation. We have a presenter today, Ron Moore. Just a quick introduction about Ron. Ron is a reliability expert and has been in the industry for close to 50 years, and he is a very famous author of 6 books on reliability and maintenance practices, and also has published over 70 journal articles in the field of reliability area. And we're super excited because Ron gives a very good perspective when you see the reliability from the safety and maintenance angle and tries to tie in both these elements together. And is a famous keynote speaker at various industry events on reliability and safety. And we are so glad to have Ron today for us to do this webinar for us. Without any further delay, I will give to Ron. Go ahead, Ron.
All right. Thank you, and thanks to the folks out there. What I want to do this afternoon is share with you some things I've learned over the years about the relationship between reliability, safety, and as well as costs and environmental performance. So without too much further discussion on the topic, let's get right into it. As most of you know, and as I'm sure it is for your organization, safety is a top priority. Everybody says safety is a top priority. They have policies, standards, and so on to support this, and they're committed to enforcing these policies. You know, I've been on sites where I've been told to hold a handrail or put my glasses on or whatever, and I think that's really a good thing, okay? And they have policy statements. I just let everybody quickly read this policy statement. And I suspect most of you out there have something very similar to this. Now, the difficulty you may run into is this so-called relationship between reliability and safety. Because I think if executives were truly committed to safety, they would be committed to reliability and would have similar policy standards and so on. And unfortunately, they typically are not and do not. And I think primarily that's because they don't understand reliability principles. Reliability is not just about maintenance. In fact, it's really more about design and operation than it is maintenance, because maintenance doesn't control the defects that create the unreliability and result in the increased risk, both to injury, risk of injury, risk of accidents, and risk of additional costs. So let's look at some examples and some data. Here's BP Texas City on the 23rd of March 2005. They were celebrating a safety award the day of the disaster, and 15 people died in that disaster. Here's another one, BP's Deepwater Horizon. That's more recent, and I'm sure most of you are familiar with this one. 2 vice presidents were aboard the platform that morning presenting a safety award. 11 people died and countless billions were spent addressing that. So, what do these have in common? Well, I think a lack of reliability and a lack of operational discipline was at the heart of most of this, So let's look at the data, the relationship between reliability and safety. Here's data from a large industrial manufacturer. On the left column, we have injury rate, and that's shown in yellow. In the right column, we have OEE, overall equipment effectiveness, and that's in the blue. And as you can see, they are inversely proportional. As injury rate, as OEE goes down, injury rate goes up, and vice versa. I have about 7 of these from various industries: food, chemicals, metals, and so on, and they all reflect the same pattern. Now, you may have a little bit different data because you're in a different industry with different variables, but the pattern, I suspect, would be very much like this. I haven't seen one yet that wasn't, and maybe it's out there, but I haven't seen it. Here's some data from a big chemical operation in Western Australia. On the left column, you got total injuries per year, and across the bottom, you've got corrective and reactive work orders per year over an 8-year period. And it's pretty obvious, the more reactive you are, the more corrective work you're doing, the greater the risk of injury. Now, this next slide is that same operation, excuse me, only this time we're looking at the PM and the PDM work orders per year. So clearly, the more in control and capable in statistical terms, the more planned and managed work you have, the lower the risk of injury. And coincidentally, the higher your OEE and the lower your costs. So here's some more data. Left column, injury rate. Across the bottom, maintenance schedule compliance. So the better your schedule compliance, that is, the more disciplined you are about your work practices, the less likely you are to be injured. Now, just a caution on this slide, and that's this. You can have high maintenance schedule compliance, just don't schedule a whole lot of maintenance. And you'll comply, hold 20, 30, 40% of your workforce in reserve. They'll be doing reactive, but it doesn't show up on your maintenance schedule compliance because you didn't schedule them. So you have to be careful with some of this data. Here's some on the environmental incidents per year. This is a big chemical operation in England. So the better your asset utilization, your OEE, if you will, the fewer the environmental incidents you have. This next one is data from 180 manufacturing plants comparing asset utilization on the vertical axis to reactive maintenance. So what this data is suggesting, the more reactive you are, the lower your OEE. This next one is from University of Tennessee. This is a survey of, I forget, several hundred manufacturing plants. And this is the average data in each of these blocks of companies. So the best companies, the best 25%, have a much lower injury rate, down near zero. The middle 50%, they're around 1, but look at the worst 25%. So clearly, the more reactive you are, the greater the risk of injury. This next one, again, several hundred companies, only this time we're looking at maintenance costs as a function of reactive maintenance levels for each quartile. And the trend there is obvious as well. And all this should help you conclude, based on all this data, that the more reactive you are, the higher your cost, the greater the risk of injury, and the lower your OEE. I mean, it doesn't take a genius to sort that out from this data. Now, this next one is vertical axis production unit costs. Horizontal axis is a thing called a reliability index. Now, this index is a composite of design, operating, and maintenance practices. And so clearly, the better your reliability practices, your design, operations, and maintenance practices, the lower your costs. And just point out the one up at the top of the graph that was closed. Well, they should have been closed, and they were closed because their costs were just out of sight. And the folks there, it came as a big shock to them, and it shouldn't have. I'll let everybody read this set of data. Here's 3 bullet points. Have a quick read of this. So, what's the implication of all this? Well, I think the implication is that you should establish a policy linking reliability and safety. So if safe behavior is a requirement and you've got standards for that, and of course you do, then operational excellence is a requirement and you have specific standards for that, and they're not optional. If you believe in 0 incidents and injuries, you must believe in 0 failures and unplanned downtime. Now, that may seem to some of you like an unrealistic thing, but I would encourage you to take that on as an aspirational goal, much the same as 0 injuries. It might be an aspirational goal. That's where you're going. You're going to work really hard to get there, and you're going to do what you need to do to move in that direction. So given all this, operations and maintenance training should be on a par with safety training, and typically is not. So getting both reliability and safety requires operational discipline, the tenacious use of best practice in all areas. Now here's a quick caution. I've seen this. Personal safety and process safety are not the same. You can have excellent personal safety and go out of business or have a major accident like BP. Personal safety is improved by disciplined use of PPE, lockout, tagout, and so on. Process safety is improved by disciplined design, operating, and maintenance practices. And you have to do both. Another way of thinking about that is this, on the left is a reliability pyramid from Winston LeDay. On the right is the process safety pyramid from Andrew Hopkins. Now, you can have lots of defects in your machinery. Those defects will create minor process errors, and vice versa. Those minor process errors can induce defects. Either way, you wind up with a major accident or a major incident. And so what you got to do is make sure you minimize the risk of defects, minimize your process errors. And so operational discipline is essential to eliminate the defects and the errors. So let's go back to that policy statement that links reliability and safety. Just let you have a quick read of that again, and then I'm going to change that just slightly by adding a couple of key words. So, all injuries and failures are preventable. No task is so urgent it cannot be done safely and reliably. Management must provide a safe and reliable workplace. We're each responsible for preventing injuries and failures, and everyone's empowered to stop unsafe and unreliable behavior. You know, given the data, if I were the boss, this would be policy. But it's up to you to determine whether or not it's appropriate for you to have that policy and to put something in place that supports that. So how do we get this reliability thing? Well, before we get to that, I would suggest to you a commitment to safety requires a co-commitment to reliability and the related policies and practices. And it should be given as much executive attention, or maybe even more, than recommendations from any high-powered consulting companies. So here's what I call the reliability process. If you really want reliability, you've got to design, buy, store, install, startup, operate, and maintain so that you minimize the risk of defects getting into your processes and creating all kinds of problems. Now, notice that there are 3 defect boxes that are bigger than the other 3. Well, what I found is those create more defects that create more problems for you. And the point of this would be, a major point of this would be, doing better maintenance will not contribute very much to reliability. It takes a holistic, comprehensive process to eliminate the defects from all their sources in order to achieve excellence. So let's take a real quick look at each one of these. Designed for reliability, not just budget and schedule. At one point in my career, I was a VP of projects. I worried more about budget and schedule than anything. And reliability wasn't really on my radar screen. It was in the sense of beating specs, but it wasn't in the sense of worrying about what might happen in 10 years. What I've found is that if you invest a little more up front, you get that money back in about a year, and I've got data that substantiate that. And if you don't do that, you're going to wind up with lower performance for the duration of the capital equipment's operation. Let's talk about purchasing. Purchasing should focus on total cost of ownership. Now, most purchasing guys, they do a good job with these first 5 bullets, price, drawings, and so on. Where they don't do such a good job, and that's partly because we don't communicate it to them, is in the performance, the maintenance, the parts, and so on. And a real important point here is that only about 25% of your total cost of ownership is in the price. The other 75 is on all these yellow bits here. So really important that you take those into account. Stores. Run your storeroom like a store, like a business. Just have a quick read of these bullet points here, and then I've got one more comment for you. Now, what parts do you need to keep in the storeroom? Well, ask yourself, what fails most often? And what parts do you need for that? And make sure you have them. Ask yourself what doesn't fail very often, but when it does, it's critical. Well, do a cost-benefit analysis on the risk and consequence of having it or not having it, and then make a business decision about that. So, various domains for stores. Reactive, you need lots of stuff because you don't know what you're going to need next, so you better have everything. And where you really want to be is proactive. You have fewer failures. And when you have failures, you know what's about to fail. You plan it and schedule it, and you take care of it. So install and start up. Here's some data. Read this data. I'll give you a minute to do that.
Hey guys, this is Banu here. If you have any questions, there is a question pane on the webinar console dashboard. Just please type in your questions and Ron will answer them at the end as the time permits. Thank you.
I want to draw your attention down to that fourth bullet, apprenticeship programs. You know, they fell out of favor some time back. They seem to be coming back into favor at this point. But notice, if you don't have a disciplined methodology for training and developing your people, they won't be able to do their jobs particularly well. So I think that's really an important point. We need more apprenticeship programs to get people properly trained in the proper practices. Operate reliably. Here's a quote from a guy named Charlie Bailey. He says, reliability cannot be driven by the maintenance organization. It must be driven by the operating units and led from the top. Charlie tried to get reliability by driving maintenance to do condition monitoring, predictive maintenance, planning and scheduling, and so on. And he got improvement, but not much. It wasn't until he went to the operating units and told the operating managers, the production managers, you're going to drive reliability. And he held them accountable for maintenance and repair costs and unplanned downtime and maintenance schedule compliance. And he held the maintenance guys responsible for on-time delivery. Now, when you hold both parties accountable for all those measures, they have to work together and you get better. And that's the history behind that quote. Another way of thinking about that is to expect maintenance to own reliability is like expecting the mechanic at the garage to own the reliability of our cars. That just sounds silly to me, you know. It's just hard to imagine. So if the design of the car is crappy, if the operators don't drive it properly and make sure it gets looked after, the mechanic cannot make up for that. So the same principle applies in our operating plants. Here's a little factoid for you. In most industrial operations, this would be steel, chemicals, refining, and so on, only about 10% of production losses are typically maintenance controlled. In fact, if you go study this and go to root cause, what you typically find is that 2/3 of those losses are from other issues like changeovers, rate and quality losses, raw material problems, market demand issues. You'll also find that in most operations, the 1/3 that is equipment related, 2/3 of that is driven by poor operating practices, which means that maintenance only controls about 10% of your production losses. So if you think of reliability in terms of productivity of the process or process reliability, call it what you will, maintenance doesn't control that. They're a support function to help with that, but they cannot control it. So it's really important that you start thinking about it at a systems level about all this stuff. Here's some more data. Just read the yellow bits. This is from 3 different studies. So now here's some work done by Winston Leday. He says you can go from a reactive domain, which is the most expensive, to a planned domain, which is the least stable, by being maintenance led. And you get some improvement in performance. This planned domain is the least stable because it's owned by maintenance. They're not in control. They're not driving the process. If you really want to have the lowest cost, best performance, lowest risk, get to the proactive domain. It's production led. It uses cross-functional teams. And this is based on his work, plus some work he did when he was an employee of DuPont. So to address these issues, we've got to have a good production and maintenance partnership, one that's production-led. Some common measures: consistency of operation, good process conformance, good shift handover, and operator care. The folks running the equipment treat it like it's their own, like they love it. Here's some data again from University of Tennessee, Klaus Blake. Here we got maintenance costs on the vertical axis, level of operator care on the horizontal axis. Level 1 is none, level 2 is some, level 3 is regular, and level 4 is regular PM checks and some repairs. Now these repairs are the simple repairs, like a maintenance helper might do. But it gives operators a sense of purpose and ownership in the equipment when they have to touch it and, use it and all that sort of thing. So it's really important that you have that. Last comment in this section, quote from my mother: take care of the place where you make your living, so it will take care of you. I've never understood people who don't. That machine, that process, all that equipment that you use to produce a product, that makes your mortgage payments possible. It helps you take care of your kids, to feed them and clothe them and buy them braces and send them to ball games. Why wouldn't you take care of the place where you make your living, so it allows you to take care of your kids and your family? I just never have understood people who don't. Let's talk about maintenance for a minute. Maintenance strategy for reliability is the integration of reactive. There'll always be a little bit of that. Preventive, that's time-based, once a week, once a month, and so on. Predictive is condition-based. That is, the condition because you're monitoring it, both operators and maintainers. You detect the problem, you anticipate it, you plan it, you schedule it, you get the equipment, you work with production, you minimize the consequence of the impending failure. Proactive is root cause based. That is, you eliminate the source of the defect in the design, in the operation, in the maintenance, and so on. Now, this model says maintenance is a reliability function, not a repair function. Of course, you have to do repairs, but when you do them, you're going to do them with great care and precision. You're going to take the time to do it right. But as we've seen, reliability is not just about maintenance. In fact, au contraire, it's mostly about all those other things. So here's some typical maintenance practices, mostly reactive. And by the way, reactive maintenance is work that you did this week that you didn't plan to do this week, plus whatever resources you have in reserve because you're going to have breakdowns. So it's the combination of those two. And most folks these days, 50% is probably a little high. Most folks will be around 30, 40 maybe, but it's still too high. Let's compare that to the best guys I've seen. Something on the order of 10% reactive, nice healthy dose of time-based, mostly condition-based with a nice healthy dose of root cause-based. The best guys I know, they don't do a lot of time-based intrusive maintenance. That is, once a year you replace this or you overhaul that. Mostly what they do during their overhauls is they do the work based on the actual asset condition that they found because they've got good condition monitoring. You will not achieve this level without a good production and maintenance partnership, one that is production-led. And by the way, this costs you maybe half as much as the reactive one, and you get a bonus. You get about 10, 15, even 20% increase in production. Now, here's a classical failure profile used for intrusive PM, intrusive time-based replacement. Well, it sort of makes sense except for one thing. It doesn't apply very often. Random failure pattern is far more common. Here's 30 pieces of equipment that have been run to fail and their life measured. There is no PM interval that will help you address this, time-based intrusive replacement PM interval that will help you address this. So this kind of pattern, which applies to something on the order of 80–90% of the equipment out there, is best addressed by condition monitoring, with addressing the appropriate failure modes and consequences. So here's some data on that. You have 5 different studies, different patterns. These percentages is the percent of the equipment in each of these studies that had this pattern. So the bathtub curve doesn't apply very often. The PM curve in manufacturing industry doesn't apply very often. In fact, let's go down here to this infant mortality curve. It applies most often. And if you recall, there's a much greater risk of failure shortly after startup than there is at any other time. And that's what this data is telling you. The next biggest one is a constant conditional probability of failure. That is, probability of any one machine failing is the same as any others. What does that look like? It's random. So how do we manage that? Condition monitoring, applying the appropriate technique to the equipment, considering its consequence of failure. What we're trying to do with condition monitoring is to understand the degradation process so we can avoid or minimize the consequence of failure. So we're monitoring. Here we have onset of failure. We don't detect it. Here we detect a potential failure. We hear a squeak or a noise. We let that go too long and it becomes a functional failure. And beyond that, it very quickly deteriorates into it's broken. That time interval in between potential and functional failure, that's the time we have to take action to plan and schedule, or to mitigate the failure, or to avoid the failure altogether. Now, one other point, we got to be proactive. We've got to stop or delay the onset of failure so we get longer life, less failures overall. Here's some data from John Schultz. On the vertical axis, we've got maintenance costs. On the horizontal axis, we've got percent of equipment on some sort of condition monitoring program. Now, what's that chart telling you? Well, clearly, the more condition monitoring you do, the lower your costs. But now, here's a caution. That's only if you have good work management. So you take action when you find the defect before it becomes serious, and if you're proactive about stopping the defects in the first place. From that same study, here's maintenance costs on the vertical axis as a function of percent PM, time-based work. Golly, look at that. Anything above about 20–30%, costs just go really, really high. Of course, the message here is don't do a lot of intrusive time-based maintenance. Do mostly condition-based and be proactive. That's what all this data is telling us. I hope we're applying this principle. Now, one other comment I made to the guys before we started this, the time frames for electrical equipment is, I suspect, quite a bit longer than the time frame for mechanical equipment. So all this information here has to be adapted into that particular situation. I'm a mechanical engineer, and so I tend to relate to mechanical issues. Those of you who are electrical, I think that adaptation needs to be made. Don't assume your PM is correct. You could be wrong. That's another study by John Schultz. He said about 10% of PMs in a typical plant could be used as is. Some of them you need to delete. Some of them replace with condition monitoring, re-engineer, transfer to operations, or have a dedicated lubrication function. Let's touch on the strategy for implementation. This is probably the most important slide in the whole deck. It has to be led from the top. Executive sponsorship is essential, and permission is not sponsorship or leadership. Active engagement is essential. Now, the point I'd like to make here is that As much as executives are involved in safety incidents, they should have the same level of commitment to reliability, and a reliability process that's not just maintenance driven. It's driven through design, procurement, operations, and maintenance. I've seen organizations appoint a VP of reliability or a corporate reliability manager. And then when that guy takes on that responsibility, he comes back and says, boss, the CEO or VP of operations, could you come speak to the reliability engineers next year or next month? No, I'm busy. Oh, boss, listen, when we got into this, I didn't know we were going to need a couple $1 million for this, that, or the other. Oh gosh, I don't have the money, and so on. They don't have the commitment. They need to have the commitment and understand what they're jumping into when they appoint that person, and they have to be active sponsors. They have to reward, punish, talk about, measure, demand, support, all those things. Anyways, next bullet. You got to have a good production and maintenance partnership. You got to have clear goals that are reasonably achievable. Shared KPIs. I mentioned that earlier. Production and maintenance share maintenance performance and production performance in certain key areas. That's in the annual appraisal and bonus system. And lastly, you've got to have a shop floor engagement process, including cross-functional teams, some structured improvement time. Once a month, once a week, you take a half a day or a day and you pick something that's not right and you make it right, and you disseminate that information. And then the next week or the next month, you pick something else and you make it right. You engage the shop floor. That will give them a sense of purpose, of ownership, of control, and you'll get much better results. 70% of the improvement opportunities are available from the shop floor. You just got to go talk to them and involve them. Now, let's suppose we want all this really quickly. Well, let's suppose we want it in 1 to 2 years. Well, you may have to spend 10 to 30% extra in your maintenance budget that year. Well, that's not likely to happen. And even if I could give you the money, you probably couldn't spend it effectively. So how do we manage that? We take small bites and we keep chewing. We pick something, we make it right. The money we save on that, we pick something else, we make it right, and we just continue that forever. And when you do that, by the way, you get cultural change in the organization because people expect to do that. Here's some data correlating OEE, production performance, against certain practices. I've already showed you this one. The more reactive you are, the poorer your OEE. On the other hand, the better your practices in these various areas, the better your OEE is. Now, these correlation coefficients are not particularly big. In fact, they're quite small. So what's the implication of that? Well, if you want the maximum influence any one of these parameters can have on OEE, you take the correlation coefficient and you square it. Well, what does that mean? Well, no more than about 10% of your improvement in your performance can be attributed to any one practice, which means, of course, we must be tenacious about doing many things really well. We've got to engage the entire workforce. Most of you have improvement projects. You've picked 4 or 5 things using RCM or Six Sigma or something like that. Don't forget the hundreds of little things that are going on out there that have to be addressed by the shop floor, because if you don't tend to those, they will converge and become the big ones. You've got to do both. Eliminating small day-to-day problems has a much bigger impact on results than focusing on the major failures. Engaged employees are 3 times more productive than average. But by the way, only about 30% are truly engaged. Nothing changes until the shop floor does things differently. If you want to know about the problems with the work, talk to the workers. Let's talk a little bit about leadership alignment change management. Here's my definition of leadership. It's the ability to inspire ordinary people to consistently perform at an extraordinary level. Now, I don't mean ordinary in any kind of pejorative sense. What I'm talking about here is regular people doing a superior job because you put them into superior systems. You engage them, you demand excellence, you support excellence. Leadership really begs the question, how do I get people to genuinely look forward to coming to work every day? Well, you involve them in making decisions about the work. You train and upskill them so that they can do the work better. Occasionally, you put them on the improvement team. You get them to restore something to like new. You brag on them. You thank them profusely for the good work they've done. And then you ask them, what can you do next? And it's an ongoing process. Here's Peter Wicken's leadership model. He talks about processes on the vertical axis and people on the horizontal axis. That is, on the vertical axis, the more rigorous your processes, the better you are. On the horizontal axis, the more engaged, enthused your people, the better you are. And if you have both, you're what he calls ascendant. That's the best quadrant up there because you've got engaged people developing rigorous processes. Well, how do you do that? You get the people engaged in developing your processes so they have a sense of ownership and purpose. Organizational alignment. Let's talk about that for a minute. Most organizations are not aligned. Read this. Now, let's suppose this data is just wrong. It's actually twice as good as this. It's still crap. So, most organizations don't do a particularly good job aligning, engaging, helping their folks do a better job. Think of the consequences of this if you were a coach and your team's athletes felt this way. So, why do we need to align an organization? Well, there's some work done by a guy named Edgar Schein, a book called Organizational Psychology. It's a really boring, dull, tedious read. But he says, and he's got lots of data to back this up, the process of organizing creates naturally competing groups, shifts, areas, and so on. And here's the crux of what he said, though, and this is the most important lesson on this slide. Alignment is critical where task interdependence makes collaboration essential for organizational effectiveness. That is, between production maintenance, between shifts, between marketing and manufacturing. When you have task interdependence for their mutual success, collaboration is essential. So how do we support that? Well, remind people to focus on the higher level goals. Think at a systems level. Don't try to optimize in your little silo. Develop shared measures between competing groups and partnership agreements so you're more likely to work together. Let's talk about managing cultural change for a minute. Culture, that's what people do when the boss isn't around. I like that definition. Let's read this. The best way to change and sustain an organizational culture is by first changing management behavior. But they got to where they are by behaving like they've always behaved. So there has to be some sort of compelling reason for them to make a change. Or how about this one? You cannot think your way into a new way of acting. You must act your way into a new way of thinking. And what John meant by that was, I think, you've got to do things differently, consistently, multiple times, notionally 21 times, before it becomes a new habit, before it becomes inherent or intrinsic in the way you behave. And that's part of why managing cultural change is so hard. So here's the model I use. for managing change. Step one, articulate a compelling reason for change. You got to create a little bit of positive tension. Next step, communicate your strategy, goals, and roles repeatedly. You got to say it over and over and over and over. You can't just say it once and it sticks. In fact, most of this stuff doesn't stick until you've been through it about 20 times. Apply leadership and management principles. In this model, leaders want change and managers want stability. Well, you have to have both. You got to challenge the status quo, make the change, stabilize it with procedures and standards and so on, and then challenge the next bit. Stabilize it, challenge the next bit, stabilize it. It's like a stair step. But the heart of it is this, though, this next step. Facilitate employee implementation of the change process. Margaret Wheatley said, people own what they create. So they have to be part of the creative process for the changes. They don't want to have it shoved down their throat. They want to participate. They want to advise. They want to be a part of the change process. Next step, measure the results. Reinforce good behavior. Thank you. Good job. What's next? And challenge bad behavior. I'm not happy with that. What do you think we should do differently? And then you stabilize the change in the new order with procedures, standards, checklists, audits, and so on. And you repeat the process over and over. What I found is that managing cultural change isn't something you do and it's done. It's not a project. It's on a continuum. And you've got to constantly work at it to sustain it. Excuse me. A lot of folks out there say people don't want to change. Well, maybe that's true. Maybe it's not. I personally believe that people do want to change, but there's some caveats. If given compelling reasons for change, if there's something in it for them, more secure future, better pay, less stress, less risk of injury. And most importantly, I think, is if they participate in the design of the changes. So we've got to have structured improvement time. We've got to have training. We've got to remove the obstacles, solicit and act on their ideas and show gratitude. All three ifs must be addressed, aligning employee interest and well-being with corporate interests. And like I said earlier, people own what they create. You got to help them do that. Then we're going to stabilize the changes. I've mentioned this a couple of times already. Update your standards and procedures, audit, incorporate into ISO 9000 performance objectives, and so on. Assure management stability. It is very difficult to have process stability when you have frequent management changes. If the change takes longer than executive or organizational attention span, it is doomed to failure. Constancy of purpose is essential. I know some organizations that have a policy of changing senior managers, say at a site level, site manager, production manager, and so on, every couple of years. When you do that often, all that does is induce instability, and the guys on the floor after a while become weebies. That is, we be here when you be gone. You're just another pretty face passing through. So it's really important that you've got to have this constancy of purpose. Reliability, essential for a safe, cost-effective, and environmentally friendly operation. And that last slide, just my contact details. So there we go. I think we've got a few minutes left for questions if people want to ask any.
Sure. Thanks, Ron.
We blitzed through that. So, I mentioned earlier that I'll send this to you and you can use it to make a PDF, or I'll send you a PDF and you can share it with folks that want it. Okay.
Yeah, absolutely. Ron, we have a question. What's the best way to implement this when the maintenance manager works for operations manager and the vast majority of the maintenance technicians are shift maintenance personnel?
Whoa. Well, if you don't get the site manager and his boss on board with what I've just been through, you're going to be at a severe disadvantage, particularly if you're in a highly reactive environment where this hasn't been, haven't given enough thought to what I just went through. So somehow or other, you're going to have to get those guys on board with the principles we just covered. Now, just what you might do is pick a small area and suggest to whoever's in charge that you try this, that you both be held accountable for these, what we just covered, and apply that principle. But that sounds like a really tough challenge for somebody. Yeah. Particularly if you're in a highly reactive domain. If you're in a domain, where you've got a high degree of cooperation and, the working relationship is really good, then it's going to be much easier because you can present this and I think run with it if the relationship is good. If it's not, it's going to be hard.
Okay. So I have a question for you, Ron, right? So you mentioned about the reliability and safety, the joint element here. So one thing is, when we go and talk to the facilities and the maintenance folks, we hear many people telling that there's no budget. You hit on a point, like there is no budget available when there is a proactive measure or an approach that's been put in the situation. But they're willing to throw millions of dollars when something fails. So what is your comment on that? I mean, management doesn't find monies to put in for any kind of a proactive measure or improving the reliability. However, if something fails, all of a sudden that gets a lot of traction. They don't care spending millions of dollars on it. So I just want you to comment on that.
Well, I think you actually do have the budget. You don't think you do because you think you might need, millions of dollars, but go back to that slide I put up that said, take small bites and keep chewing. Well, take small bites and keep chewing. Pick something, pick a machine, make it right. When you got that one right, pick another one, make it right. Pick a procedure, make it right. It's a slow, gradual stepping stone process that over the course of a year or two, you'll start to build credibility and you'll start to, get folks on board with doing this stuff. So I disagree. I think you do have the budget. You just don't know it. You think it's going to be a, multi-million-dollar program, and it's not. It's picking something and making it right repeatedly. Now, you may need a few $1,000s here, there, or yonder to make something right, but surely that's within the discretion of the management team to do that. We aren't talking about, chunking whatever $2 or $3 or $4 million into a program. We're talking about a change in mindset, a change in the approach to engage in the workforce and setting higher disciplinary standards for the workforce itself, higher expectations, and then supporting them meeting that expectation. All this is really a question of leadership. All right, I've yammered on enough.
Thanks, Ron. I mean, guys, if we have a few more minutes, so if you have questions, please do use the webinar dashboard and type in the questions. And as the time permits, as I mentioned, we'll answer the questions. So I don't see any questions coming on the webinar console.
I'll give him a minute to.
So what is one of your biggest challenges when you communicate about reliability to your end customers, Ron?
Probably the bigger challenge, I think, is the distraction of the day-to-day urgency, emergency of the moment. It reminds me of folks who have these cell phones, and every time it dings or buzzes, they've got to grab it. Well, you don't need to grab it. You don't need to run to it every single instant where you have a little blibbit. You got to be more disciplined about how you apply the work principles and the work practices I just took you through. And yeah, occasionally you may need to do something that's urgent or an emergency, but that ought to be the minimum, not the routine. So I really, again, it's a question of leadership and setting higher standards and expectations, and then allowing the people, engaging the people, and doing what they can do and do it well. No questions, apparently.
Looks like it's okay. Exercising preventive safety practices is the responsibility of everyone. Looks like it's a statement. So,
Yeah, it is. I mean, safety is everyone's responsibility. Reliability is everyone's responsibility in their own domain, in the world that they live in, that they're responsible for. They have to focus on defect elimination and reliability practices as much as safety practices. Because if you have better reliability, you'll have less risk.
sure.
So,
As
yeah,
go ahead.
amen to that. That's all I was going to say.
So as I went through the slides, on the very initial slides, you mentioned about the total cost of ownership,
Yeah.
but also you made a point about the shared KPIs. Do you want to expand on that? What do you mean by shared KPIs? Because when people try to design the systems, they just look at the price perspective, just as initial cost of that machinery or the equipment. They don't look through the entire life cycle. And when you meant the shared KPIs, when those decisions are made, we just want to know your standpoint. What does that really mean?
Okay. Well, I mentioned one example. You know, production and maintenance are both, the managers are both held accountable for maintenance and repair costs, on-time delivery, production and maintenance schedule compliance, things like that. Because in most organizations, the production guys, right, they're held accountable for quality, on-time delivery, and they don't really much care about the maintenance costs. On the other hand, the maintenance guy is held accountable for maintenance costs and maintenance schedule compliance. Well, he doesn't control that any more than he controls production delivery compliance. So having them share those fundamental measures forces or facilitates, at the very least, their cooperation to make thoughtful decisions about what they do and don't do. Another example would be on stores, you know, your storeroom. The storeroom manager in most organizations doesn't want anything in the storeroom. That's working capital, not working. The maintenance manager wants a spare plant. Well, neither one of those is compatible with a good operation. So you make them both accountable for inventory levels, inventory turns, and for stock out rate that impacts maintenance costs and production. Hold them both accountable for that and let them balance the competing interests. In projects, I would hold the project guys responsible for applying life cycle cost principles and for the unit cost of production during that first couple of years of operation. Because if you can't deliver the product at a quality and cost effective way, then you haven't done the operating plants any favors at all. And I would make the maintenance engineer the project engineer, the maintenance engineer for 2 years after startup. So when they start to make decisions that are dumbassed, they suffer the consequence of that because they have to take the phone call at 2:00 on Saturday morning. So it's those kinds of things that you set an expectation within the workforce that they're going to work together to drive your reliability up, your costs down, and your performance up. That has to be created by the leadership. And if they don't do that, and if they foster these silos, then you're going to get siloed behavior and ineffective performance. Well, I went on a bit, but that's my answer.
Sure. No, that's great. Yeah. So I think you kind of answered what the KPIs you recommend. So that's one of the follow-up questions that came in as you're speaking.
Yep.
What KPIs do you recommend? I think between the operations and the maintenance kind of thing, what you answered, I guess.
Yeah. Now, I can send you, in fact, I will, just remind me if I forget, I'll send you a set of slides on, I think I call it key performance measurement principles.
Okay.
And it covers those points I just made. And it also provides for leading, give some examples of leading indicators, what the shop floor does, and lagging indicators, the results you get. And I think most people give too much attention to the lagging indicators. Well, that water's already gone over the dam. So what are you going to do with the leading indicators so that your folks will be able to do things right, so that the lagging indicators, the results you get, are better? I'll send you that.
Okay, that's good. So, a quick note again, there'll be a exit survey as you conclude the webinar. Just please make sure that you give your feedback and take the survey, which will help us to get the better content out on our future webinars. And also, as most of you know, Grace is in the electrical safety and predictive maintenance areas of business, and we do have certain products that will help you solve some of your reliability and safety needs. So please do take the survey and let us know if you're interested to learn more about the products and how we can help you in your reliability and safety journey. We'd be very happy to do so. Please just let us know through the survey. Okay. Yeah, I don't see any additional questions coming in, Ron. So yeah, thanks again, everyone. Thanks, Ron, for taking your time and presenting.
My pleasure, guys. Thanks for joining us, and I hope you found some of this information useful that you can go back and actually apply it within your operation.
Yeah, and if you want to know more about Ron, you can just Google his name and it'll show up too many things. So you can just click and learn more about Ron Moore itself.
Well, I don't have a website, and I don't do LinkedIn, so you may have some difficulty, but
Okay.
All right.
Ron. Thanks for doing this for us. Okay. Thank you, everyone, for joining the webinar, and have a wonderful rest of your day. Bye-bye.
All right. Thanks, guys. Bye.